Hey everybody, so we are now moving into our rational functions unit. We're going to start with graphing, so you do need graph paper. All right, what is a rational function? So if you remember what a rational number is, we always use the definition that a rational number is a number with, that can be written as a fraction, right? So it's not like a square root. So a rational function is a function with a variable in the denominator. So our parent function for rational functions is 1 over x. That's our parent function. And we've looked at these when we talked about domain and range, but now we're going to really get into it. So if you think about the domain of the parent function, it's that all real numbers except, because you can't have 0 in the denominator of the fraction. So we have weird things happening at the denominator. So the domain of this is all real numbers except what can you not have in the denominator? X equals 2. That will give us a weird thing happening. With the range, we talked about how it's going to be all real numbers except y equals 0. And the reason is, think about if I try to set 1 equals x, if I try to set this equal to 0 and I cross multiply, I end up getting 1 equals 0, right? And that doesn't work. So that's why there's you can't equal 0. So then what happens when you get really close to those, right? So when I get close to 2, what's happening to the graph? If I plug in 1 over 1.9 minus 2, a number really close to 2, what's happening there? I get 1 over negative 0.1, which is negative 10. So 1.9, I'm at negative 10. I'm like down here. What if I plug in 1 over 1.99 minus 2? What does that give me? 1 over negative 0.01. So that's 100. So as you get really, really close to 2, the numbers are getting like really big. So the graph ends up looking like that. Let's say I plug in 10, right? If I plug in 10 into my function, let's do it this way. So if I plug in 10, I get 1 over 8. That's a pretty small number, right? So I'm on the wrong side. I'm like here, right? What if I plug in 0? I get negative a half. So I'm here. What if I plug in negative 10? Negative 1 over 12. So we've kind of seen this before, and it kind of looks like this. But we're not going to ever hit 2. Now, what if I go on the other side? What if I put in 2.1? If I put in 2.1, I get 10. 2.01, I get 100. So kind of the opposite thing is happening. Just to the right of 2, we're getting numbers that are crazy high. I plotted that point wrong, didn't I? Why do I always do that? It's so annoying. All right, let's fix this. When I plugged in positive 10, I get positive an eighth. So it looks like this. Right. So this is the general, what this thing typically looks like. And so that whole x equals 2, x can't equal 2. What we're going to do is x equals 2 is actually a line, right? It's a vertical line. So that graph is never going to cross it. X equals 2 is a line. Y equals 0 is also a line. That's y equals 0 is this. Right? So that's y equals 0, and then x equals 2. So we're actually going to be using those. Right? It's those are called asymptotes. All right. What is a vertical asymptote? It's a vertical line that a function, I'll just put a graph. It could be not a function. A graph approaches, my iPad just fell over, approaches or gets close to but usually doesn't cross. All right, so I'm going to say usually. Pretty much you'll see that it doesn't cross. There are very rare circumstances. I don't even know if we're going to get to them. But sometimes with an asymptote, you can cross it. The ones we're doing, we're not going to be able to cross it. Okay, how do you find the vertical asymptote? All we're doing is set the denominator equal to 0. So when we set the bottom equal to 0, so when that last one, x minus 2 equals 0, we had a vertical asymptote at x equals 2. So basically it's the domain, it's where the domain can't be equal. Domain can't equal. So you find where's the domain, that's your, where's the domain not going to be, that's your vertical asymptote typically with these. All right, and then the horizontal asymptote is a horizontal line, a graph approaches. And now here's how we find horizontal. Usually doesn't cross. Imagine you're plugging in a really, 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 really big number. What do you get? So we're thinking about the end behavior. End behavior. Plug in a very, very large number. The y value is your asymptote. So for that last one, if we plug in 1 billion, if I plug in 1 over 10 to the 9th minus 2, I'm basically getting 0.00000 whatever 9. So I'm getting basically it's approximately 0, and that's how you find your asymptote. So if I plug in a really, really, really giant number, what's happening? What's the y value getting close to? It's not always 0. We're going to look at ones where it's not 0. All right, so we're going to start with our vertical asymptote. That's just setting the denominator equal to 0. So if I set the bottom equal to 0 and solve, I get x equals 5. Pretty straightforward. Horizontal asymptote. If I plug in a very, very, very large number, what do I get? 2 over 1,000,000. 6 zeros. It's about 0, so that means it's y equals 0. Typically, as long as there's no variable in the numerator, it's going to be 0. So now what we're going to do, what I like to do is I like to use a highlighter or a marker and draw those. So y equals 0 is my horizontal line. So there's my horizontal asymptote. And then my vertical is 5. 1, 2, 3, 4, 5. I wish I could make the highlighter a little smaller on here, but... And these are, remember, these are lines. So pretty much these always look the same. So now, here's what we're going to do. I have a good idea about what this looks like because it looks like the parent function. So we want to find, my goal is to find 4 points on this graph. So if I look at this, what number can I plug into this and get a nice answer? So if I have x minus 5, I'm thinking to myself, what will give me a 1? If I plug in 6, that gives me 2 over 1, which is 2. If I plug in negative 4, that gives me 2 over negative 1, which is negative 2. So that's typically where I start. I'm going to set the bottom, I'm going to set the bottom equal to 1 and negative 1. But I usually don't write it out. I just kind of think about it. And then the other thing I do is, what will make the fraction cancel? So what will give me a 2 on the bottom? Since the top is a 2, what will give me a 2 on the bottom? So again, in my head, I'm thinking x minus 5 equals 2. Okay, so if I plug in 7, and then 2 over 2 is 1, and then x minus 5 equals negative 2. I just turned my pen off. That gives me 3, negative 1. So these are the points that I'm going to plot. And again, all of this, I don't actually write that out. I just do it in my head. All right, so I have 6, 2. That's a point. I have 7, 1. I have negative 4. That was supposed to be a 4. 4, negative 2. And 3, negative 1. All right. So those are the points I'm going to use. And I'm just going to draw in this curve. Pretty much these all look exactly the same. There's not a big difference. And that's it. That's my graph. Every single graph is going to look something like that. I'm just trying to get a good idea about what it is. Okay. So I want you to pause the video, find your asymptotes, and find points on the line. So my vertical asymptote, I'm not going to write out the word vertical asymptote every time, is x equals 1. My horizontal asymptote, if I plug in a really big number, it's close to 0. I'm going to use just the pen for this one. And the asymptotes are always dotted. Notice I was doing that. It's a dotted line. And then 1. So that first one took a really long time. This usually doesn't take that long. Okay, so now I'm going to pick 4 points. So to the right of 1, I'm going to start with 2. If I plug in 2, I get negative 3 over 1. And then what will make the bottom negative 3, negative 2, 1. And then we've got, 0. If I plug in 0, that gives me a 3. And what will give me a positive 3? 4, negative 1. So those are the points I'm using. So I've got 2, negative 3, 0, 3, negative 2, negative 1, negative 2, positive 1. Just kidding. Watch your signs on these. 0, 3, 1, 2, 3, and 4, negative 1. So no, think about the difference between this one and the last one. There's not a big difference. The difference I see is that the points are a little farther away. That's about it. When you have a number in the numerator, it will make the point, it won't get as close to where the asymptotes are intersecting. There's another difference. What did that negative do? It flipped the graph. Before, in that last one, it was like that and that. The negative, it just reverses it. Like every other graph we've ever graphed. It just flips it upside down. All right. Now this one is going to change our horizontal asymptote. So let's look at this one. So vertical asymptote is still, where's the denominator equal to 0? X equals -2. The horizontal asymptote, though, if I plug in a really, really, really big number, I get -5 over a billion, right? Well, whatever that is. So 0, but then I have -4. So y equals -4. So when you have a number there, that's typically your horizontal asymptote, as long as you don't have any x's in the numerator. We're going to do those on a specific day to show you what happens there. So I have x equals -2. Y equals -4. So in my head, I know, okay, there's a -5. It's going to flip. It's going to be something like that, right? But let's find 4 points so we can be semi-accurate with this thing. All right, so again, I'm going to plug in numbers. Now be careful with the plugging in with this one because of that -4, right? Y equals x plus 2 minus 4. All right, so I'm going to start by plugging in -1. -1 gives me, I'll go over here, -5 minus 4, which is -9. Sometimes you do end up having to plug in, like, and deal with decimals. Let's see, if I plug in -7, right, -7 would give me -5 over -5, so that's -3. Let's see, if I put in -3, that gives me -5 over -1 minus 4, which is 1. And then what would give me 5? 3? 3 would give me -5 over 5 minus 4, which is -5. All right, those are my 4 points. So again, I'm literally plugging in, guys. -1, -9, -7, -3, -3, +1, and 3, -5. So again, notice that now we have a 5 in the top, so these points are a little even more far apart than they were. That's a graph. All right, last one. Pause the video, try it on your own. All right, so I'm going to go through this fast, like how I think about it. So vertical asymptotes. X equals -5, the bottom equals 0. Horizontal asymptote. No x's on top, so it's just 3. So I got -5 and +3. All right, now I'm plugging in some points. So let's see, I'm going to plug in -1, because if I plug in -1, that gives me 4 over 4 plus 3, which is 4. I'm going to plug in -6, because that gives me 4 over -1 plus 3, which is 2. What will give me a 4 on the bottom? That's a -1 will give me 4 on the bottom, so that gives me 4. And a -4 on the bottom would be -9. So that would be -1 plus 3, which is 2. Did I do that wrong? I already have -1, 4. Oh, I didn't. I was supposed to plug in -4. What was the other one I have to plug in? -4, 7. Let me just check. That's 4, -4, and 3. That's wrong. -4 and 3 is -1. 9, that gives me -1 and 3. Okay, I think I'm right now. Oh, it's so easy. This is what I get for trying to go too fast. -1, 4. -4, 7. 3, 4, 5, 6, 7. So there's that graph. And then I got -9, 2. And -6, -1. It's really hard to draw on here. All right. That's the lesson. Practice. See you tomorrow. Bring questions.